Good afternoon. I would like to start my talk with asking a few questions to you. First of all, who of you has an electrical car? Nobody? Okay, more or less what I expected. But how many of you do have a smartphone? Okay, so I think all of you do have a smartphone. And do you know where the minerals in your smartphone come from and in your laptops and so on? Well, for the moment they mainly come from landmines, but in the future this might change and they might come from the ocean, from the regions which are indicated by the gray boxes here on the map. Because in these areas, at the depth of about 4,000 to 5,000 meters, there occur these kinds of stones, which are called polymetallic nodules, and they look like this. So they're not that big, they look like this, and they can reach high abundances in the deep sea, creating so-called nodule fields. And I've put them under this glass bell because they're very important and they're very valuable from an economic point of view, because they contain a high amount of minerals like cobalt, nickel, copper, and as well rare earth elements. And in the near future, mining companies, they're planning to mine these nodule fields, extract the mineral resources and use them in state-of-the-art technologies, like the smartphones in your pockets. So they're important from an economic point of view, but even more important is that they're very valuable from an ecological point of view, because they largely influence the faunal communities in the deep sea. They influence the abundances, the distribution, but as well the community composition of these organisms. And we rarely don't know anything about it. So therefore, we went to the Pacific Ocean, somewhere in between Hawaii and Mexico, to visit these nodule fields. And we wanted to collect quantitative data on the macrofauna in the area. So we used box scores to take samples in the 3 areas which are indicated by the red boxes. And these areas, they represent all similar habitat types in terms of environmental variables like granulometry and bathymetry. So what we found was that this macrofaunal community in these nodule fields is mainly dominated by polychaetes and isopods, but as well by amphipods and tannates. And abundances, they reached on average about 200 individuals per square meter, and they belonged to at least 92 different taxa, of which most are unknown to science. We also compared the community composition and the abundances between the different sites we sampled, and we didn't find any significant differences. So we can conclude that these macrofaunal communities are rather homogeneous between the different sites, but they're very diverse, and this homogeneity might dampen the expected consequences of the mining activities by the recolonization of animals from unimpacted areas. However, we highly recommend a precautionary approach because there's still a lot of unknowns. We don't know a lot about spatial and temporal scales, for instance. So, if we want to get a more realistic view of these macrofaunal abundances in nodule fields, we should get a better idea of the regional heterogeneity in the area, the habitat heterogeneity. And this can mainly be achieved by a better habitat mapping in the area. So, if you think about replacing your smartphone in the next coming months or years, think twice about the possible consequences this might have for all these mysterious and poorly known species that live in the deepest parts of the oceans. Thank you.